3.1 Understanding Polynomials. We're first going to start off by looking at what a monomial is. A monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Terms of an expression are parts of the expression separated by plus or minus signs. Remember that x minus y can be written as x plus negative y. A monomial cannot have more than one term, and it cannot have a variable in its denominator. So if we look at this table, we're asked whether or not it's a monomial. So 5ab squared is a monomial. X squared is a monomial. The square root of y is not. 2 squared is a monomial. 5 over k squared is not a monomial. Remember, you can't have a variable in the denominator. 5x plus 7 is not, because there's more than two terms there. Or sorry, there's more than one term there. And then x squared plus 4ab is not, because again, there's more than one term there. And then k squared divided by 4 is the same thing as 1/4 times k squared, so that is a monomial. If we look at the next part, we're looking at polynomials, which are monomials that have more than one term, so these are now called polynomials. If they have two terms, they're binomials. Trinomials are three terms. A polynomial is anything more than three. The degree of the polynomial is the greatest value among the sums of the exponents on the variables. So if we look at the first example A, we have 7x squared minus 5x cubed y cubed. This is a binomial because there's two terms. And then the degree is the sixth degree because we're going to look at the x to the third and the y to the third and add those exponents. So 3 plus 3 is 6. If we look at b, we have 3 squared, which is 9, plus 2n cubed plus 8n. This is a trinomial because there's three terms. And the degree on it is the 3. If we look at example 3, it asks us what is the degree of 5x to the power of 0, y to the power of 0 plus 5. And that degree is just 0. Those zeros as those exponents turn the x and the y to be a 1. And any number raised to the power of 0 is itself, or 1. So if we have 5 to the power of 0, or sorry, 5 times x to the power of 0 is 5 times 1. And then y to the power of 0 is also times 1. So 5 times 1 times 1 is just 5. It says for 4 is 5x to the power of 0, y to the power of 0.5 plus 5 a polynomial. Justify your answer. It's not a polynomial, so this is no. And the reason why is because the variable y has an exponent of 0.5. So for our next example, we're classifying these polynomials and giving its degree and the number of terms. So there's, for 5, we have 3x squared y squared plus 3xy squared plus 5xy. So there's how many terms here? There's 3 terms. It is a trinomial. Oops. And the degree that we have is 4. Oops. 2 e's. There we go. If we look at the next one, we have 8ab squared minus 3a squared b. So this is two terms, so it's a binomial. And then the degree, if we add those degrees, we have a to the first plus b to the second, so 1 plus 2 is 3. Look at the the negative 3a squared b to the first. That's also 3, so this is to the third degree. If we look at our next example, we are writing the standard form of a polynomial and identifying its leading coefficient. So for example 2, we're writing each polynomial standard form and giving the leading coefficient. The leading coefficient is the number in front of the variable that has the highest value of the degree. Okay, so if we look at example A, we have 20x minus 4x cubed plus 1 minus 2x squared. So we want to have the term that has the highest exponent come first. So that's the negative 4x cubed. Then it's going to be the one that has the 2, so that's negative 2x squared. Then the 20x, so plus 20x, and then the plus 1. So we want our variables to go in order from greatest to least based off of their degree. From here, it asks what the leading coefficient is. Your leading coefficient here is that negative 4. So negative 4 is your leading coefficient. If we look at b, we have z cubed minus z to the 6th power plus 4z. So that negative z to the 6th power will come first, then the z cubed, then the 4z. Our highest exponent there is the 6, so that our leading coefficient is the negative 1. If we look at example 7, we have 10 minus 3x squared plus x to the 5th plus 4x cubed. So that x to the 5th would go first, then the 4x cubed, then the minus 3x squared, and then the plus 10. The leading coefficient here is that 1 in front of the x to the 5th power. We're going to look at 9 first before we go to 8, just because we're in the same screen. So we have 10x plus 13 minus 15x squared. So the first thing that we're going to write down is that minus 15x squared, then the 10x, then the 13. Your leading coefficient is the negative 15. For 8, they give us 18y to the 5th minus 3y to the 8th plus 10y. So that negative 3y to the 8th will go first, then the 18y to the 5th plus 10y. And our leading coefficient is the negative 3. And then for 10, we have negative 3b squared plus 2b minus 7 plus 6b cubed plus 12b to the 4th plus 7. So this negative 7 and this positive 7 are going to combine to cancel out. And other than that, we can't combine any other like terms. So we're just going to put this into standard form. Our first term is going to be the one with the highest exponent, which is the 4. So 12b to the 4th. Then we have 6b cubed minus 3b squared. And lastly, that 2b. So the one with the highest exponent there is that 4. The leading coefficient is 12. When we simplify polynomials, we are combining like terms. So if we look at the next example, we're combining like terms to simplify the polynomial. So we have for a negative 2y cubed minus 8y squared plus y squared plus 2y cubed. So the negative 2y cubed and the positive 2y cubed are like terms. They're actually going to cancel out. And then the negative 8y squared plus y squared is negative 7y squared. For b, we have p squared q cubed, and then we have minus 4 p to the 5th q to the 4th minus 4 p squared q cubed plus 3 to the 5th p to the 5th q to the 4th. So the p squared q cubed minus 4 p squared q cubed is going to be negative 3p squared q to the 3rd power, and the negative 4p to the 5th q to the 4th plus the 3p to the 5th q to the 4th is just negative 1p to the 5th q to the 4th. If we look at those next examples for 12, we have 3p squared q squared minus 3p squared q to the 3rd plus 4p squared q to the 3rd minus 3p squared q squared plus pq. So the 3p squared q squared minus 3p squared q squared are going to cancel. Then you have another set of like terms, which is the negative 3p squared q to the 3rd power plus 4p squared q to the 3rd power, which is going to give us a positive p squared q to the 3rd power. And then lastly, we have that p times q, which is just plus pq. We're going to do the same thing we did on the other page, do the 14 first before we move to the 13. So for 14, we have AB minus A squared plus 4 squared minus 5AB plus 3A squared plus 10. So you can rewrite this to where this 4 squared is 16. So then you have the 16 and the 10 that are like terms. Start with your highest exponent. Your highest exponent here is the negative A plus A squared, negative A squared plus 3A squared, which is going to give us a positive 2A squared. From there, if we look at that negative 5AB and that positive AB, this is going to give us negative 4AB. And then lastly, we have that 16 and the 10, which we add together to get 26. So 2A squared minus 4AB plus 26. For 13, we have 3 times A plus B, which is going to turn into 3A plus 3B, minus 6 times B plus C, so distribute that, so negative 6B minus 6C, plus 8 times A minus C, so plus 8A minus 8C. So combine your like terms now. The 3A matches up with the 8A. So 3A plus 8A is going to give us 11A. Then you have the 3B and the negative 6B, which is going to give us negative 3B. And then lastly, you have the negative 6C minus 8C, which is going to give us negative 14C. So for 13, our answer is the 11A minus 3B minus 14C.